Hello, everyone. Welcome to Oracle CloudWorld. My name is Ali Mukadam, and I'm a cloud solution architect working on Kubernetes and cloud native at Oracle. Today's session is about deploying Kubernetes in the cloud. This session is inspired by the character of Boromir in Lord of the Rings. Just as one does not simply walk into Mordor, one does not simply deploy Kubernetes in the cloud. Now, deploying Kubernetes involves making a choice between two types of clusters. One is what we call a self-managed cluster, and the other one is a managed cluster. A self-managed cluster is you can run these on premise or in the cloud, whereas a managed cluster is usually run in the cloud. However, the difference between these are in terms of your responsibilities as a user. For self-managed clusters on premise, you basically have to handle everything, including your power, your rack, your hardware provisioning, your software installation and upgrade, your handling high availability, and eventually you have your application deployment as well. Typically, this will involve different type of teams. So you can have a data center team, you can have an operations team, and you can have an application team. You can use self-managed clusters in the cloud as well. With difference is that now the hardware provisioning and this is being handled by your cloud provider. Essentially, now what you need to do is that your operation team has to handle the setting up of the clusters, the software installation, the scaling, and the high availability and security. And your application team has to manage your application and its deployment and its upgrade. In contrast to self-managed clusters, whether in premise or in the cloud, managed clusters is the bigger part of the entire operation is handled by your cloud provider, including your hardware, including your software provisioning. What you need to do as a customer is more or less focused on deploying your application, and you don't need to handle the software installation of Kubernetes itself. You don't need to handle the high availability. So that leads to some very interesting choices and a kind of what you need, advantages and disadvantages. With self-managed clusters, you have greater control in terms of how you want your clusters to be. You have almost zero lock-in, and you have an almost complete choice of technology stack. However, this also means that it requires more effort. You need a more skilled engineering team and a more skilled operations team as well. And given the Kubernetes is a rather complex software, it also entails higher costs. In contrast, manage clusters. The benefit of this is because you're not handling the lower level stack, the lower level operation, that leads to lower costs. So you focus more on the high level stack, typically your application, and less on the lower level operations, and less effort is required. Some of the disadvantages, though, is that it gives you less control, and you essentially sometimes have to choose to get by with what the managed service is giving you in terms of the technology stack. So to that end, how do we go about provisioning clusters on OCI today? When we talk about using self-managed clusters, you can use any infrastructure as code tools, such as Terraform, or you can use OCI's SDK as well. You can also use Cluster API, which is a sub-level Kubernetes project, and we are going to talk about this a little bit further during this presentation. For the managed clusters, what we call OKE, affectionately in Oracle, You can use, again, an infrastructure tool such as Terraform or the SDK. The cluster API is in development at the moment. Cluster API is technically also an infrastructure tool, as code tool. The reason why we are distinguishing it here is because it tends to focus more on provisioning Kubernetes clusters only, whereas a tool such as Terraform, you can do a lot more than just Terraform. You can do other provisioning, including on OCI, such as your network, your databases, etc. So to provision OCI, Kubernetes clusters on OCI, in this session, we are going to look at two of them. One for self-managed cluster, we're going to look at cluster API, and then for the managed OKE clusters, we're going to look at how to use Terraform. So we'll start with OKE and a quick introduction of OKE. OKE stands for Oracle Kubernetes Engine. It's a certified Kubernetes conformant cluster. It's straight from upstream Kubernetes. We don't add any secret sauce to lock you in. Right from the get-go, there's advanced security implemented, including private clusters, image scanning and signing. You can choose to encrypt the underlying etcd, even though you don't have access to. So your data and your deployment data is safe. There are simplified operations that we handle on your behalf, including making the entire control plane highly available, the scaling of the worker nodes, and in case of some of the worker nodes not responding, it has the ability to self-heal basically. It's available. Okay, clusters are available as a day one service in all 40 regions, and including on dedicated regions as well. So as we add more and more regions worldwide in Oracle, OKE is available as a service. There's a rich set of compute shapes available for you to use, including ARM shapes, x86, Intel and AMD, bare metal, VM, and GPUs as well. So this gives you a predictable and consistent performance for your applications, regardless of the type of application. And unlike a lot of other cloud providers, there's no cluster management fees for the control plane. This runs at Oracle's cost, and if you are running a large number of clusters for different projects or for different environment, this can save you quite a significant amount of money. So let's look at deploying the OKE. Now, what we have done in Oracle is we have developed a Terraform module for OKE. We are doing this in open source on GitHub. This is the URL over here. And this involves making a few infrastructure decisions, especially around networking. Typically, you would need to have a virtual cloud network, or what we call VCN for short, a number of subnets, including for your workers, for your load balancers, for your control plane. But what we do further is that we make some explicit and deliberate choices in terms of your load balancers. Load balancers in OCI and for Kubernetes can be both public and private, and we make it in such a way that the subnets are separate. So your load balancer subnet, your public load balancer subnet go into public load balancers, and your private one can go into a private subnet. You can use these to further deploy additional OCI services, like for example, if your application or API driven, you can and need to be publicly accessible, you can use the OCI gateway and place in the public load balancer subnet. Similarly, there are separate subnets for the control plane and the worker nodes as well. The worker nodes are the control plane are has a private endpoint, and by default, the worker nodes are private as well. So which means that users are not able to reach the VM or the compute instances where you're running your application directly. In order to interact with the API service, especially to do deployment, to do administrative operations, we need to therefore we need to be able to reach the API service. If we are running this as a private, then usually that's not possible. So what we have inside the project is an internal host with the necessary rights to interact with the control plane. We don't put the, any authentication keys. Rather, we use a feature in OCI that we call instance principal. Instance principal basically gives a VM limited access to perform some kind of operation, and essentially kind of designate this instance as a trusted host, and it can perform these type of operation. In this case, it's about retrieving the kube config, as well as running additional commands like deploying your pods or deploying your ingress controllers or even running Helm commands. On this, we in the project, there's also pre-configured network security groups, and we disable the security list manager. In doing so, this helps you control your environment, and all of this can be configured as well. Now, when you deploy your, after you have created the network, you want to be able to deploy your application. Typically, these would run on your worker nodes. The way OKE deploy worker nodes is using a concept called a node pool. And think of a node pool as a cluster within a cluster, and all worker nodes in this node pool have the same profile. Basically, it has the same shape, it has the same CPU architecture, it has the same amount of memory and disk size. And when the good thing with OKE is that you can choose to deploy your application on multi-CPU architectures, all of these within the same cluster. So it can be Intel or AMD, or it can be ARM, or it can be GPU, depending on the needs of your application and your workload. Similarly, instead of just doing a multi-architecture, you can have mixed performance as well, depending on the needs of your application. You can size the node pool differently. So in addition to changing the shape, such as VM, bare metal, or GPU, you can also change the size of the node pools as well. And all of these are happening within the same cluster. To push this idea further, what can be done is you can create specialized workloads. Like, for example, certain nodes such as these worker nodes, they can be living at the edge. Why? Because they are responsible for deploying your ingress controllers. This is where the load balancer would typically be interacting with before they reach your other applications. Similarly, you can have a management cluster to run cluster to scaling or monitoring or general kind of workload. If your application are AI oriented and you have tasks that need to be run in parallel, you can use GPUs instead. But whereas if your application or the tasks are more sequential in nature, you can choose to run using bare metal instead, because these tend to be more memory intensive usually. Likewise, some applications are more stateful, so you need to have some kind of a storage, so you can create specific node pools that are more suitable for this kind of application. In doing splitting your workload in these various type of node pools basically allows you to tune these various node pools according to your needs. Um, on OKE, we use a software package called TuneD, and it comes with TuneD comes with predefined performance profiles. So there's for power saving, but there's also for low latency, high throughput network and virtualization performance. We're on all the node on all the node pools. We're already aggressively running performance boosting profiles. But if there is a need for you to further tune based on your own application requirements, you can use the TuneD and configure this via cloud in it for all the specific pools. These node pools, you can create some of those yourself and create your own profiles and based on your application needs. Now, usually most customers would be using more than one clusters, and whether it's for high availability, whether it's for different types of environment or different applications. The neat thing with the OK module that we have built with Terraform is that it's reusable. So you only need to change a few parameters to provision a new cluster. So for example, if you want to deploy in a new region, you would set the new regions parameter, the different CIDR blocks for the VCN, and the routing rules depending on the visibility of your cluster, whether it's public, private, whether you are using some of the OCI services. If you have two different clusters running in two different regions talking to each other, so you would use DRG and OCI remote peering, and in this case you need to make sure that the side blocks of the different VCN do not overlap each other. So when using multiple clusters, especially if one of your clusters is in a different region, what happens under the hood is that for the last few years, we have been using kubeconfig v2 in order to access and interact with the API server. Now, kubeconfig v2 requires authentication with every call. Usually, that's in the form of a token. Under the hood, what's happening is kubecontrol uses the OCI CLI to get a valid token, and then it allows you to interact and do your deployment or whatever operation you need to do with OKE. This adds if it's happening in the same region, that's fine. It's not necessarily a big deal. However, if you're interacting with a region that is sufficiently removed from where you are, this can cause a little bit of latency or more of an annoyance, especially. So what we do in the kubeconfig module, in the OK module, I'm sorry, is to cache the valid token, and on average, this improves the API calls to by a significant amount. The tokens are valid only for about 4 or 5 minutes. That's a kubeconfig spec, and then OCI will get, when this token is no longer valid, the OCI CLI under the hood gets a new token for you. In addition, what we also do is we add a couple of additional tools from the community for kube context and kube namespace, and this, in the context of working with multiple clusters, this simplifies your mental model of working with those clusters, with multiple clusters. Basically, in this case, you can you can equate one context to one cluster. All right. Now this is for using um, and for provisioning and using uh, OKE as a managed cluster. Let's now look at provisioning self-managed clusters using Cluster API. First of all, why use self-managed clusters in some users, they have a need and desire, or even the perception for to have greater control. They want to have less lock-in. Even though Kubernetes is pretty neutral, even though on OKE we don't implement any lock-in mechanism. They need to meet specific technical requirements regarding scale, regarding the use of um, container native networking interface, regarding security, regarding maybe storage, or maybe even compute images. So, or they might need to meet some non-technical requirements, such as organization policy, industry regulation. These are some of their requirements. Other users, they have a need, instead of just doing it, they want of meeting certain specific requirement, they have, what they're doing is they are replicating an on-premise deployment in the cloud. The reason for doing this is presumably they are using the cloud only for non-production use. And for their production deployment, because of regulation or other policies, they need to deploy on premise. But for cost saving purposes, they are using the cloud. Or others may be just seeing how well their setup work in the specific cloud providers. Some users want to run some kind of a hybrid clusters because they want to pin certain application to some worker nodes, and some worker nodes may be required to run in their own on an on-premise set of compute. And lastly, because some people can, it's an intellectual challenge. And these are some of the reasons basically to use self-managed clusters. Now, I want to refresh your memory a little bit about this slide. When using self-managed cluster, there is still a fairly significant amount of work that you need to handle as a customer, even though you're running on the cloud. And that includes the software installation, the upgrade, the platform backup, the high availability scaling. And you can do this using a tool like Terraform. However, we've had experience with this. Before KE was available, we used to run a GitHub project to automate the installation of a self-managed Kubernetes on OCI. And maintaining such a script, even as a vendor, is quite hard because there's a number of uh, of variations involved in deploying a software like Kubernetes. This is where Cluster API comes in. So Cluster API, the way it works is that I want to make an analogy here with WebLogic. WebLogic is an application server from Oracle, and it runs on an operating system. So something such as Linux or Windows. It uses Java as a runtime, and it consists of two types of servers. One is the admin server, the other one is a managed server. And we're going to look at what each of these does in a minute. Likewise, Cluster API, instead of an operating system, there's an infrastructure provider. Usually that's a cloud provider. And each of the cloud providers have their own implementation of Cluster API. So we have implemented a Cluster API for OCI, just as the other cloud providers such as Azure or AWS have implemented theirs as well. VMware has one as well. Now, the equivalent of for the runtime this time is Kubernetes. So instead of Java, you have Kubernetes. And similar to WebLogic, you have, instead of an admin server, you have a management server. And instead of a managed server, you have a workload cluster, right? Now, what do how are they similar and how are they different? So in WebLogic, what you would do is that you would use the admin server to manage an application. So using the admin server, a WebLogic admin would deploy an application, and these applications would be running on the managed servers. Now, for Cluster API, instead of managing application, the management cluster, it manages other clusters. So it handles the provisioning of the different clusters, or what we call different workload cluster to be more accurate. You can also use the management cluster to upgrade, to delete, and to scale. This is the purpose of the management cluster. And on those workload applications, you will still be running your application. However, those are applications are deployed by some other mechanisms, like maybe using your CI/CD tool, or such as OCI DevOps service, or if you want to roll your own using something like Argo. These you would use some kind of a tool to deploy your application. The key point is that the model is kind of the same, at the same time is a little bit different. And this table summarizes the similarities and differences between them. So WebLogic Admin Server manages and deploys the application, which are run on managed servers, whereas the cluster API management cluster provisions workload clusters, and these operate at the infrastructure layer. Now, how to use Cluster API? You can use this to provision multiple clusters in different regions. As an example, I have a management cluster here that's running in the Frankfurt region, and a Cluster API admin is using it to define multiple clusters in different regions. Now, the same approach I can do this. Do that using Terraform. That's not a big difference. Where Cluster API really shines is when you have to deploy different clusters in on many infrastructure providers, or using different type of clusters, or cluster software. So, for example, here I have an application that's running on, or I have many applications that are running on different type of clusters, but I want to provision one cluster here on OCI, another here on Azure. Here, this may be running on one of the infrastructure providers, but instead of using, one of the self-managed clusters, I'm using K3s, which is kind of suitable for running on the edge. Or I may have a need to run something on premise as well. So maintaining Terraform scripts for each of these providers is a very tedious and time-consuming task. And what the Cluster API does is it provides a similar experience to creating and managing and upgrading all these clusters from one single management cluster. So kind of a one cluster to rule them all and bind them in the cloud, if you will, as a analogy to Lord of the Rings. Now, just as one does not simply walk into Mordor, like you can go through the usual path, or you can go through Isengard, one does not simply deploy Kubernetes. You have a need since many people are going to be using multiple clusters, you have a need for cluster management software. We need to handle the identity and access management. We need to handle cloud native security, which in itself is quite a a a broad topic. You need to handle the runtime, the design time. You need to handle the hardening. There's also observability, storage. Um, Maybe you might want to use a service mesh. What software you're going to use for CI/CD, how you're going to implement network policy, or if you have a need for a cluster mesh, when you're deploying, whether you're deploying on multi-cloud or not. All of these different categories of or the different tasks, they involve making a choice of some additional software that's going to be running on Kubernetes. And if you look at the cloud native, the CNCF landscape, in each of these, there's many different type of projects. Sometimes they are competing with each other as well. And you as a user, you sometimes end up having to evaluate each of these software. Some of them are pretty popular. They are very well known, like for example, Helm, org, or Prometheus. They become a kind of a de facto choice or standard. Some others, you need to evaluate them for your own needs. And given the wide variety, and this is a very fast-moving space as well, evaluating each of these it takes a fairly significant amount of time. What we have from Oracle is an enterprise container platform. We name it Verrazano, after a bridge in New York. Think of Verrazano as the fellowship of the ring. So it's open source, it's curated, and it's an opinionated container platform. You can run it on a private cloud, a public cloud, or multi-cloud as well. As long as you have a Kubernetes cluster, you can deploy Verzanos on any cluster anywhere. It uses a set of robust, well-proven community projects, including Prometheus, OpenSearch, FluentD, Istio for service mesh, Keycloak for identity access management, Rancher for cluster management. And we are developing this as in the open source. So we add a number of open source CRDs and controllers, and we handle the integration, the versioning, compatibility, the security, the integrity, etc. For your application, there's also support for various type of Java frameworks, including Spring Boot, Micronaut, and Helidon. In doing so, what Verrazano provides you is a consistent container platform for all your applications, and regardless of where you're running. As long as you have a Kubernetes cluster, you have the capabilities of Verrazano, and it's ready for day one and day two operations. If you're running on premise as well, it's hybrid ready. Verrazano provides a pathway and simplified tooling for your J2E applications. Basically, if you got J2E applications running on for example, on WebLogic, you can bring cloud native to them rather than ripping and redeveloping your application from scratch. So straight away, you get the observability, you get enhanced security, and high availability that comes with running on top of a Kubernetes cluster. You can take this opportunity to then migrate your J2 application to the cloud and to a more microservices architecture. And then basically you can do that at your own pace. If you have a need to go polyglot, that's entirely possible with Verrazano as well. Now, not Verrazano does not just provide you a bunch of software to monitor and develop your application. Just as what Cluster API does for your self-managed clusters at an infrastructure level, Verrazano does it for your application as well. So using it has a similar concepts like an admin cluster and managed clusters. And the admin cluster handles the operational aspect of your application, such as deploying and placing your application. For example, here I have two workload clusters running in Sydney and Melbourne. I'm placing this Spring Boot application in Sydney, and then this Helidon application, which requires coherence in Melbourne. I can also choose, and the admin cluster for Verrazano, I chose to run it on premise. So all I need to do is interact with this admin cluster, or rather get my CI/CD tool chain to interact with the admin cluster of Verrazano to do the deployment of the application. Instead of manually deploying to getting my CI/CD tool chain to manually interact with both clusters. To take this idea a little bit further, I can also choose to deploy it to the same application in active or uh, DR or in DR mode. So if it's active, for example, what we can further do, especially if we need to expose our application publicly, is this is going to be under the hood here. There's going to be an ingress controller, which will have a load balancer exposed publicly on both clusters. What what you can further do, especially using OCI health check and traffic steering, is that we can set up a bunch of health check that point to those load balancers and make sure that our application are still available. In case it's active, both the traffic steering returns both of them as part of an Ansible to DNS, which then returns this to the end user. In case it's active, it's a DR kind of deployment. In case one cluster goes down, maybe for maintenance reason, we don't need to change anything in the DNS. Traffic steering is going to handle that automatically for us. The moment this health check fails, because presumably we have brought this cluster down, then traffic steering through the health check detects this and instruct DNS to only return the DNS record for the Melbourne region. So in this way, you can have a number of you can have different type of deployment options, whether active, or whether you can do whether geolocation, and all of these clusters are being deployed either using Terraform or using Cluster API. Now, if Cluster API is the ring that binds us all, then we need to also find a way to monitor multiple clusters at the same time in the cloud. But typically that involves, for monitoring purposes, Prometheus is very popular. However, Prometheus is not highly available. And there's another project called Thanos in CNCF that makes Prometheus become highly available. And the way to you can run Thanos on OCI, this is one of the ways, by the way, is in the Prometheus pod. there's a Thanos container which runs, and what the Thanos container does is it keeps the last 2 hour, the metrics of the last 2 hours from Prometheus. It reads this and it stores this locally. For those that are longer than 2 hours, they are written back to OCI object storage. And if we want to have that historical long-term metrics, there's a third component of Thanos that's involved. It's called the Thanos store, and we expose both of them using Thanos query as an internal or private load balancer. Now, why we expose this as the private load balancer is because we don't want our data to traverse the public internet. Rather, what we do is we set up peering between two VCN, presumably maybe in different regions, using DRGs on both VCN. So now both VCN can talk to each other, and a Thanos query component can talk to another Thanos query and basically aggregate the data when needed. So when an administrative user needs to analyze the performance of a particular cluster, maybe or for a particular time period, what the Thanos query does is it does what we call downsampling. It extracts the data for that particular time period only. And Thanos the various Thanos components, including the sidecar, the query, and the store, they all have Prometheus compatible API, which means that you can use a tool like Grafana and point to any of them and create your dashboard for monitoring purposes. So you have using Thanos, we have that you can now monitor your regions and your applications at the same time wherever they are running, and these can be either on OCI or they can be on other cloud providers as well. To summarize, you can run different type of clusters on OCI and different cloud providers or infrastructure providers. These can be managed Kubernetes clusters or they can be self-managed. On OCI, managed Kubernetes clusters are called OKE, Oracle Kubernetes Engine. You can provision them using Terraform or Cluster API, although the Cluster API implementation for OKE is currently in progress. And the use of common multi-clusters are quite common already. What's different is that users are taking tentative steps towards deploying clusters in multi-cloud providers. And as a result, Verasano is well positioned to handle the cluster management, the application management, the observability, and the service mesh, and much more than that. So basically, when you combine multiple cloud providers with multi-cluster capabilities in Verasano, you achieve what we call cloud native nirvana. This gives you you realize the true power of Kubernetes and cloud native. It's not a question of cloud native. It's not a question of where, but how you run your application. With this, this is the end of my presentation. Thank you very much. Enjoy CloudWorld.